Okay, mic check, we rolling? Good deal, here we go. Okay, good morning, Cisco cohort guys. Okay, so here's what's going on here for the rest of the semester. Today's Tuesday is going to be our last real lecture where I'm going to cover more like a lab demonstration of the frame relay. If we were still in the classroom, meeting in the classroom, then on Thursday would be our practical lab skills exam. So since we ain't going to do that, Thursday's just going to be a work day. There'll be no lab, there'll be no sync session on Blackboard Collaborate. Just you catch up on your chapter exams and your labs that are required for this. Hold on, someone is joining us in attendance. A week from today is the scheduled final exam time. Now, if we were meeting in the classroom, you'd have to show up exactly at like 9:30 and take it from 9:30 to 11:30. But the dean has asked us, in this case, since people are home, to give a little leeway. So the final exam, which will be open book, will be available all day Tuesday. I'll turn it on probably a little bit before 9:30. I'll probably turn it on more like 9 o'clock in the morning. You still only get 1 hour and 45 minutes to take the exam. The practice final has been activated. There's a little difference between the practice final for these and the earlier practice finals you guys were used to. I was able to go in and click the box that says students can view answer and item feedback, and you could sort of print it as a study guide. The new secured practice final doesn't allow that. But all you get is a generalized course feedback form, which I consider pretty useless. It just, if you miss a question, it sort of points you back to the page and chapter of the book, the ebook that you missed on. I have also activated the CCNA certification 200-301 practice final. That's also a secured exam. You can take that and get an idea of what the real certification exam would be, the one you're allowed to take from home or office now. You can do that since April the 15th. But you only get course feedback. You don't get individual item feedback. You can't see the answers on that one either. I put up this link again, careercert.info. You can download free PDF files for like the Cisco Pressbook and the Todd Lamley titles and the CCNA command reference guide. If you create a free account in the system, you can also download some video CCNA stuff. Really big downloads. It's like 2 or 3 gig of video files, but there's no charge for it. Let's see, 1, 2, 3, 4, 5, 6. Okay, so before I go into the lab demo, I want to show, oh, wait a minute, someone's got a comment. Do I have a practical app prepared? If so, can we get a copy for practice? Casey, do you mean a practice examination thing? Is that what you mean? Because the Career Cert guy sells for $16 or something. He sells a practice exam for the 200-301. No. Oh, the in-class live final. Well, there'll be no in-class live final. Instead, just the 5 or 6 labs that we did are only going to be the 50% of your grade, and there'll be no separate 25% for the in-class live final. That's not going to be required. If you were still coming, yeah, you would have to do that stuff on Thursday. So we don't have to do that. Okay, someone just joined. Hey, Liz. 1, 2, 3, 4, 5, 6. 4, 5, 6. Okay, what I want to share is, since I'm going to talk about frame relay today. 1, 2, 3, 4, 5, 6. What am I missing here, Casey? There we go. Okay, what I want to share is click share, application window. So we haven't talked about encapsulation types. Frame relay, they used to be frame relay and point-to-point protocol in this last 8-week semester thing. The default type, this section here is working. If I put it on here. Oh, there we go. All right, so I did show interfaces 000, and I haven't done no shutdown command. There's no IP address yet. This is going to be the machine I'm going to do a frame relay demonstration later on. Encapsulation type, HDLC. That's the default encapsulation type for all Cisco serial ports. That's back in the early 70s, there was an attempt made to standardize the encapsulation type of all serial ports between all manufacturers' devices, and it was supposed to be HDLC. But they put a vendor frame bit in there where the vendors could make them more specific, and so as a result, Cisco and all the other networking vendors made theirs slightly different from everybody else, with the result that if you had like a Cisco router on one side of a leased T1 line and another vendor's router like a Nortel or some other brand on the other side, they wouldn't be able to transmit the information back and forth to each other. This problem was solved by, you guys remember America? Maybe you don't remember. Maybe you weren't born then. It was America Online and Star Text, and everybody dial up their bulletin board systems with dial-up modems. And these dial-up modems there was like 10,000 different makes and models. But they all spoke a common protocol called point-to-point protocol, PPP. So that way, it doesn't matter what brand of modem you had when you dialed up somebody and what brand of modem that they had, you could still establish a connection with them. And point-to-point protocol also includes such things as, like when you logged into America Online, it would check your name and your password, make sure your bill had been paid up to date, and then it would grant you a session and you could go browse to America Online and the beginnings of the internet that was back then. So we used to cover point-to-point protocol because that was a solution if you had a Cisco router and you bought some other company and they had other brands of routers like Wellfleet or Lucent or something, you could configure your router serial ports to both be point-to-point protocol, and that's an open standard. So to think of if we had two Cisco routers that were speaking the EIGRP routing protocol between each other, and then I brought in another brand of router that was not Cisco. The other brands of routers that are not Cisco, they don't have EIGRP because that's proprietary to Cisco. But we could use an open standard protocol between the two routers. We could have them both speak OSPF. So I could run point-to-point protocol over my T1 link between two different brands of routers. I could configure both routers to speak OSPF for their routing protocol, and I could be up and running even though the vendors didn't match, the models didn't match. So in the serial world, we're allowed to change that. But by default, HDLC, high-level data link control, was originally intended to be an open standard, but it didn't turn out to be an open standard. So in the old Cisco curriculum, we would cover point-to-point protocol, we would cover the old ISDN, dialer maps, thank God we don't have those anymore, and frame relay. So I'm going to give a demonstration today of frame relay. And think of frame relay kind of like, this is the reason that frame relay was so popular. Back in the early 90s, if you had 10 branch offices, you would have to run 10 T1 lines from the home office data center to each of the 10 branch offices. And each of the 10 branch offices would have a little remote Cisco router with one serial port to connect to the T1 line, and an Ethernet port to attach to the switch at that remote location, the Ethernet switch to plug all the employees into that router so they get connectivity back to the home office. But back at the home office, it was a real nightmare. We had 10 DSU CSUs, 10 serial cables, and we had to come up with a Cisco device that had 10 serial ports on it to connect all these together. We configured the 10 serial ports for the T1 protocol and get them connected. It was a big nightmare with 10 modems and 10 power supplies and 10 serial cables and big expensive Cisco routers that had 10 serial ports on them, that rather than an expensive serial Cisco device that just has a couple of serial ports on it. So when the frame relay came out in the early 90s, this was what we did was essentially duplicated what you're already familiar with. Inter VLAN routing. I can have 10 VLANs with 10 different broadcast domains in my company for my 10 different departments, and I can trunk those together over one trunking cable and plug that into one single Ethernet port of one router and configure inter VLAN routing on the router, and it could go back and forth and route step between all those 10 departments at that office. So we're going to expand this to the WAN, and with frame relay, we're going to, instead of doing inter VLAN tagging, we're going to use a DLC, a data link connection identifier. We're going to mix together the frames over the WAN connection from our 10 branch offices and have them come back to our home office. through one serial port, through one DSU, CSU. So no big complicated wiring mess at the home office. So all those 10 remote branch offices can come into one serial port of a much less expensive Cisco router, and then the Cisco router can use that. Instead of using Ethernet subinterfaces, G00.10, G00.20, we're going to use subinterfaces on the serial port. So the S00.122 and S00.221 or whatever our Delcy numbers are. So when we did inter-VLAN routing, we would always make the dot number of the Ethernet port equivalent to the VLAN value. So if it's VLAN 10, we make it G00.10. And we try to make the third octet of the IP address have the 10 in it as well to make it easier to troubleshoot later. So we can do the same thing with Frame-Relay. Now the demonstration I'm going to give today is just going to be a single point-to-point circuit. I'm not going to use sub-interfaces. I'm just going to use a simple Frame-Relay circuit of home office to branch office with not a bunch of sub-interfaces. But if you're interested in that stuff, well, in theory, I've got a couple of PowerPoint slideshows that I posted in the PowerPoint presentation slide that gives you more information on that. So how do we change? Here we go. How do we change the encapsulation type? Because its default, it was HDLC. So I'm going to go to the configuration mode. And interface S0/0 on this machine. I'm using the GNS machine. It's a 00/0. So encapsulation type. There are possible encapsulation types here. Well, they put in their routers everything we used back since, dirt. So Frame-Relay, HDLC is the default type for Cisco routers. Point-to-point protocol. X.25 was the old grandfather of Frame-Relay. So there's quite a few to choose from. So if I want to do changes from encapsulation Frame-Relay, I would just type encapsulation Frame-Relay and change it from HDLC to Frame-Relay. And I'm going to do that on the configuration of this. So I'm going to show it at Packet Tracer first, and then I'm going to show it to you in a more that was more like that lab that you guys would have done in the lab if you were here, but I'm doing it today as a demo. So let's just look at that laboratory. So if I put my mouse here, okay, the mouse is working here. So here's our standard 3 router topology in the CCNA. We're at R1, R2, and R3. In this case, R2 is going to be the Frame-Relay router. Really not a router, we're demoting the router to the switch. So we're taking it down from a layer 3 device to a layer 2 device. I'm going to use a simplified version of this lab. I'm going to show you how to do it in Packet Tracer first. Now, the problem with Packet Tracer is this Frame-Relay code they give you don't work in Packet Tracer. Oh, Elijah says, is there a printout for this lab? And the printout is indeed in the student lab printouts section of my TCC Blackboard Frame-Relay. And let me show you what that is. Stop sharing this. So if you go to the, oh, I have to be in the mouse in the right way for this to work. If you go into the student lab printout section, this laboratory is the configuring Frame-Relay for IP version 4 and IP version 6. I'm not going to perform this entire lab. I'm going to do a very simple demonstration just with IP version 4. Frame-Relay with just plain old IP version 4 when it was first came out in the 90s, it's very simple to configure and very easy to get up and running, particularly on a simple point-to-point circuit such as this. Okay, so let's see. I'm going to go into Packet Tracer now. Stop sharing this. And let's see. I'm going to share application window. Oh, my friend's here. Where is it? Oh, it's in the bottom of my screen. Okay, so here's Packet Tracer. And I'm going to sort of duplicate the setup here. Now, I'm going to use a little trick in Packet Tracer, which is I'll go and click on Devices. And instead of picking and having to provision the serial port on this device, I'm going to go through and pick, there's a pre-configured 1841 router that already has serial ports configured. So when you float over it, it says, oh yeah, it's already got the serial ports installed. Because normally if you pick the 1841 router by itself or the 1941 router, it only has the Ethernet ports configured. It doesn't have any serial ports, so you got to turn off the power switch and plug in the card and turn it back on again. So this is just a little quick way of getting this going. So I'm going to configure this to be, let's see, oh, it pops it up in the right place this time. Wow. So I'll go to the config and I'll make this R1. And I'll go to, this is going to be R3. And then the one in the middle, I'll call it FR for frame relay. Oh, I'm sorry, I can't do that. It doesn't work. After that, it doesn't work. I can't do it. I can't use this device. Oh, we're gonna. Let's see. I'm just dragging this over here. This is the problem in Packet Tracer. I can't do those lines of code in Packet Tracer on that frame relay one, so I've got to use another device here. Let me find the other device. So we're going to use a cloud device here, and it can be configured with frame relay, but it's not iOS commands. It's just picking stuff from the menu. Okay, so I'm going to configure the frame relay connection first, and let's connect it up here. So I'm going to hook R000. I'm going to hook that to serial 1 of the cloud connection. This is the simulation of the frame relay providers, stuff in the cloud that you don't have any control over. And I'll pick 0001, and I'll connect it to serial port number 2. Now let's configure that device. This is shown here. Okay. So we're going to go to config. I'm going to go serial port 1. And let me talk a little about DLCs, data link connection identifiers. So in the world of Ethernet, you have a MAC address, a 48-bit MAC address that maps to a layer 3 IP address. In frame relay, what we want to do is we want to map, instead of a 48-bit MAC address, we're going to map an 8-bit data link connection identifier. And it's going to serve a similar function to the Vlan tagging ID that's on 802.1q when we do VLANs and framing and VLAN routing. So I'm going to make up a DLC value here. I'm going to call it, this is going from router 1 to 2, I'm going to say it 1 to 2. And we have to give it a name. So I'll just call it DLC 1 to 2. We're going to take the dash, let's see. All right. Now on serial port number 2, I want to map the reverse connection from the other branch office back to that connection. I'm going to call it 2 to 1. And we'll just give it a description name of DLC 2 to 1. I'll add that in place. Now I'm going to go to the frame relay part and click serial port number 1, which goes to my router number 1, and it's DLC 1 to 2. Now click serial port number 2 and click add. And that configures it there from a menu thing. And when I'm going to run this again in a moment in GNS and show you how it works in GNS too, we can actually put the code in it. But in Packet Tracer, their routers aren't real iOS. It's kind of simulated, kind of like a Mac Media Flash stuff. So we got the connection going on those guys. All right, now let's go to the router and configure it. Very simple configuration here. I'm going to go to CLI here. You already put the host name in for me? So I'm going to go say interface S0/0/0, and I give an IP address 1.1.1.1 and /30, and then encapsulation type has to be frame relay because it's going to a frame relay switch. That's all the difference. Normally I would have to put the IP address, and do the no shutdown command. That's the only difference here. Now let's go to R3, do a similar configuration. Oops, made it too big off your screen. There we go. Go to the CLI. Okay, let's say interface serial 0/1, 0/0/1. In the GNS, it's only 2 slashes, and the real newer routers, it's 3 slashes. IP address 1.1.1.2. Encapsulation Frame-Relay. No shutdown. I'm not going to get real big into the Frame-Relay technology here, but Frame-Relay has got a thing called inverse ARP. And think of what ARP does. ARP sends out a broadcast message that says, if you have this particular IP address, please tell me what your MAC address is so I can put this in the Ethernet frame with your MAC address and put that in the destination and send it to you. So in Frame-Relay, we've got a thing called inverse ARP. So what happens is the router in R1 is going to send out an inverse ARP message saying, if you've got this delc value, tell me what your IP address is. I want to map the layer 3 IP address of the router on the other end of the T1 line to my delc value so I can encapsulate your values. And if I got 10 branch offices, I'm going to use these delc values like VLAN tagging values would be on inter VLAN routing and keep them separate from each other. And this automatically takes place. This is a Cisco proprietary protocol that's the most common one in the world that will automatically send the delcs from one to the other. They'll do the mapping. Inverse ARP is on by default, and they'll map it for it. And it usually takes about a minute to do this. And in the time it took me to tell you about this, this has happened. So what has happened is that the Frame-Relay mapping, the inverse ARP, let's look at the mouse moving here. Is the mouse moving here? Okay. So this is R3. Let's do show IP interface brief. Show IP interface brief. And this is the router on the right-hand side. His address is 1.1.1.2. He's up and up. If I had not changed the encapsulation type, it would have been up and down because the up wouldn't have been the wires plugged in the physical layer. The protocol wouldn't match. Frame-Relay doesn't match HDLC. It would stay down on that. But it matches the Frame-Relay switch, so it's okay. So the address of this device is 1.1.1.2. Now that line above it, show Frame-Relay map, he now knows that 1.1.1.1 is the IP address of the device on the other side of the link, and that's matched to his delc 221, which is my level of mounting for router 2 back to 1, 2 to 1. So I should be able to ping 1.1.1.1, and I can do it okay. Okay, let's go to router R1 and see if he's okay. He's still in here? Here he is. So show Frame-Relay map, and from the standpoint of router R1, his serial 00 port, which actually connects to the Frame-Relay switch, and then the Frame-Relay switch connects to serial 001 on the other router. So he has aligned that 1.1.1.2 address of the router on the other end of the least telephone line, the least Frame-Relay link, to his delc 1 to 2, which is his knowledge of. Delcs are like MAC addresses. They're locally significant. No one cares about your MAC address unless they're in the same room with you. Once you're in the rest of the world, every time you go through a link, the MAC addresses constantly change from link to link. Your IP address never changes. So the word dynamic means inverse ARP did this. Now, if in this lab, if you read through the lab, he'll say, don't use inverse ARP. It's dangerous. It could map something up before you're ready to do it. And they tell you to do no Frame-Relay inverse ARP and do manual Frame-Relay mapping statements. But inverse ARP works quite well for a simple point-to-point link. Now, if you did have a home office and 10 branch offices, you might want to do that and use manual Frame-Relay mapping statements, which are kind of similar to IP mapping statements, to establish that relationship between the layer 2 delc address and the layer 3 MAC address. Okay, so I got connectivity here, and here's a weird thing about Frame-Relay. Let's see if Packet Tracer does this properly. What's my IP address? Show IP interface brief. IP is so close to the caps lock key. Can I ping my own IP address? Should I be able to ping my own IP address? Hey, look at that. Frame-Relay. You can't ping your own IP address. He'll tell you in the lab, oh, you have to do a manual Frame-Relay Delcy mapping statement to do that. So that upsets a lot of people. That upset me the first time I did this because I'd always been able to ping my own IP address before. Okay, so that's how it's done in Frame-Relay. And now let me minimize this, minimize this. Oh, it's going to cause my thing to freak out here because he can only share screens that aren't minimized. And I'm going to try to repeat this in not in Packet Tracer, but let's see. Okay, I got to stop sharing that. Share the application window. I'm going to use the GNS program, which is a free program you can get. They don't give you the iOS file, but I've got some iOS files on Cisco24.com, a real good one, the 3725 file that works with this. So in this case, I'm actually going to be able to, this is actually running the real iOS. It's an old iOS, it's version 12.4. That's almost 10 years old already, but it's going to work just fine. So what I'm going to do is, in this time, instead of actually Frame-Relay, there is a Frame-Relay switch code, and it's set up similar to, very similar to the one I showed you in Packet Tracer. Instead of using the R2, I could have put the Frame-Relay switch in there and connected to that, and then just go in there and go into a little menu and key in 1 to 2 and 2 to 1. And it would have worked, but I wanted to demonstrate to you guys how to demote a perfectly good $1,000 Cisco router into a $100 layer 2 switch. So that's what I'm going to do here. I'm going to use that instead. So I've got these plugged together. There's no configuration on these devices. This is the R2 I just used a second ago to tell you that show IP, show interfaces, and it was HDLC type. So we're going to go into that router, and let me see. I'm going to temporarily share. I'm going to temporarily stop sharing this and start sharing that lab because I have to turn to the page with that code on it. So let's see, where is the lab? Here it is. So in our GNS router, it's S00 and S01, and it's F0, F01. I'm not going to use host machines. I'm just going to do the same thing like I did before and ping from router to router. Okay, so sorry on your eyes here. I got to roll down to the section of code here, and we're going to configure this in Frame-Relay router. Okay, I'm going to do this part right here. I'm going to configure the Frame-Relay switch. Okay, I'm going to go back to I have to pop back now to the screen with the GNS in it, and I've got this on my other part of the screen that you can't see right now. If I put them both on the screen at the same time, it would be too small for you to see it. It would look like this. I'll show you just to show you what's going on with this screen sharing program. So in theory, I should be able to share an entire screen, but it's really clunky looking, particularly if you're on a small thing like that. So there's the lab on the right, and there's a GNS on the left. But I'm going to just share the GNS screen so it's full size. Okay. So here it is here. Now I got to bring up the router R2 and put it on. And let me see. I think this is the case that if I bring it to the foreground, it doesn't pop to the foreground. I have to actually share it separately. So I'm going to bring R2 to the foreground, and we'll configure that. This is the same screen I showed you earlier when I was doing the encapsulation Frame-Relay. Bring focus to the window. Okay, I'm going to go to the configuration mode, and to make it match the lab, I'm going to change the host name to Frame-Relay. And then what we're going to do now is we're going to demote it to a Frame-Relay switch. So I should be in the configuration mode, Frame-Relay switching. Okay, that makes it a Frame-Relay switch. Now let's go to the 2 serial ports and configure them with a couple of lines in each one, so they'll be the Frame-Relay switch for this. So I'll say interface S0/0 on our machines instead of S000. Remember that thing I did before, encapsulation frame relay? I'm going to do it now. On HDLC, I've got to be frame relay to match those two end routers. Okay, another statement, and this is a kind of esoteric statement. Frame relay, INTF type, DCE. Remember DCEs and DTEs? DCEs are data communication equipment like a router, and a DTE is an endpoint, customer endpoint like a DCE is like a cable modem, and a DTE is like your home router. It doesn't really matter whether if you're in a lab situation where you have DCE, DTE cables, whether physically it's a DC or DTE. This is a logical thing. It's just a statement that has to be put in to make this work as a frame relay switch. Now I'm going to put in the mapping. I want to put a routing statement in there. So frame relay route, and I'm going to use the one in the lab so I don't get confused here. 103, and I'm going to go to interface S0/1. S001 and 301. So that establishes the mapping between the first serial port and the del C that you should see from the other side. And finally, I'll do notion. Now, let me do the same thing for interface S0/1, and it'll have the reversed values. So first thing I'll do is encapsulation frame relay. Frame relay INTF type, DCE, then frame relay route 301 to interface S0/0 103. I've got my matching statements in here. I can do my shutdown. And then the lab instructs you to type the command show frame relay permanent virtual circuit. We've set up a permanent virtual circuit from this standpoint. And we can see that it's inactive at this point, because there's going to be a procedure where they're going to go through and send out the inverse ARP requests back and forth to each other. It takes about a minute or two, and when that finally occurs, they should be able to talk to each other. Okay, so I'm going to minimize this. Oh, I better stop sharing it first too. For free. Okay, now I need to bring up R1, and let's configure R1. Okay, so let's see. This should be R1. I've got to bring focus to it. I'll click on your broadcast image. Okay, so the only thing that's been done on this router is this R1. So if we do a show IP interface brief, we don't care about anything except serial port is 00. We're going to configure with an IP address and change the encapsulation type to frame relay, and that's it. That's all we've got to do. And then once we do router R3, they should be able to ping each other. So I'll go to config mode. This is exact real-world configuration. The provider has pulled a frame relay T1 line to you from point to point. They put in DSU, CSU. You plug in the cable to your router, and this is all the configuration you got to do to get the frame relay connection up and going. Because the provider will take care of what we did on R2 in the middle of the frame relay switch. Okay, so interface serial 0/0, encapsulation type frame relay, IP address. I use the same address I did before, not the one in that. Now, inverse ARP works great with IP version 4, which is what we used as a legacy for many, many years. If you're running frame relay with IP version 6, that's kind of an odd combination. A 40-year-old technology with a brand new IP v6 technology. So normally, if you're running IP version 6, you're probably not going to be running frame relay, but it works. The inverse ARP doesn't work. You have to do the manual frame relay mapping statements, and that's going to be on the scope of what I'm showing you guys for today. Okay, so it's up and up, and that's all I can do on that one. So I'm going to stop sharing that, and let's configure the other router. Okay, so I'll do a show IP brief on this guy. It's totally unconfigured. The only thing we've done is the R3 host name. So I'll go to the configuration mode and say interface serial 0/1. The GNS image only has that numbering scheme. Encapsulation, change it from the default HDLC to encapsulation frame relay. And then IP address 1.1.1.2, 255.255.255.252. Do a no shutdown. It's going to take a couple seconds for it to come up. But let me do a show interface serial 0/1 on this. And the encapsulation is type has changed to Frame-Relay. It was HDLC before. It takes a couple minutes for it to come up and out. LMI, the logic, the managed face, this is the Cisco proprietary thing that sends out queries and finds out what the DELC address on the opposite side was, and it will just take a few seconds. Well, it'll take about a minute for this to take place. So if I do a show Frame-Relay mapping, oh, it worked. It didn't take very long. So we're seeing the very thing that we see on the other side. Should I now be able to ping that 1.1.1.1 address on the other side of the lane? And it works just fine. Now let's go back to that router R2, just as a matter of curiosity. I'm going to go back to that router R2, stop sharing this, share the R2 screen, because that statement I did on R2 before, short Frame-Relay PDC, it was inactive. And the first row says active, it's active now. So the first serial port is active to his client machine R1. Second port is active to his. So we can see what's going on. This would be similar to the commands that the actual service providers would use when they provided you a Frame-Relay circuit. Pretty cool, huh? Frame-Relay stuff. Very simple to configure on a point-to-point circuit. Now, if this had been a more complex circuit with a home office and 2 or 3 branch offices, if you're more interested in this stuff, in the PowerPoint slideshow, they have some stuff about creating the sub-interfaces and how you use a different broadcast domain to go to each different branch office, just like we'd use a separate broadcast domain when you're doing inter-VLAN routing to go each department, and you give them VLANs 10, 20, 30, and things of that nature. Okay, where did it go? Oh, did I minimize it? Oh, there we go. Okay, so just to real quickly review what's going on here again today. I covered the Frame-Relay lab demo. There will be no sync session on Thursday. That's a day if we were actually in class, we would do the skills demo, the skills lab thing, but the skills lab thing, we're not doing that time. And instead, your lab score is going to be entirely based upon these 4 or 5 labs that we actually did. The course feedback form is up. Remember that you go into your assignments on NetAcad and look for course feedback form. And there's a Cisco has a business requirement, a business rule that you must take their course feedback form before you take the final exam. So if you want to do that anytime and get that out of the way, you won't have to worry about it until a week from today when you take your final exam. Okay, the practice CCNA exam is up and the practice final is up, but they're the new Cisco security exams, and I just cannot allow you to. Oh, Elijah asked the questions on 4227. Wait a minute, which one is the English? 1 second. Oh, the lab, this Frame-Relay lab is not required for you guys to do. I'm doing this as a demo. Everybody gets credit just by being here and watching. If you want to do this on your own, as for your own instruction, you can do that, but you're not required to turn it to me. And so this is a type of lab where it's got, almost all the answers in there if I had to sign it for you. So don't worry, but you don't have to perform this and turn it in. Oh, chat, I'm being inundated with chat. Hold on. Okay, so don't worry about doing this. So Casey's question: Is there a skills exam? No, no skills exam. Elijah's question: Oh, how do we do out the questions on this 4227 lab? You don't have to do this. If you want to do this on your own, just for fun, you can do this. You'll have to do it in Packet Tracer using that cloud thing that I showed you, but you don't have to do this one. You will not be able to perform this lab in Packet Tracer using the technique in this lab because it assumes real routers. If you download and load the GNS program and get that 3725 iOS, it's on my Cisco24.com site, you could do this at home with the GNS stuff, but that's kind of overwhelming to do all in one go for one lab if you've never done this before. So you are relieved of the awesome duty and obligation of having to do that. Okay, careercert.info, free PDF. I don't know how he does this. He's got free PDF downloads of books that are only $40 or $50. Looks like a fairly legit site. He's been up for a long time. It would seem to me that Cisco would try to put him down for this if he was doing something wrong. So he's got the Cisco Press books, the Wendell Odom books. He's got the Todd Lamley book, which is a Dallas-based trainer who has these two are the best-selling CCNA prep titles. He's got the 31 Days to CCNA. He's got the CCNA iOS Command Reference Guide. And if you register on his site free, give him an email address. He'll send you a link to confirm what your email address is. Then you can also download some video tutorial stuff on CCNP. He's got more advanced material too, like on CCNP. Okay, so our final exam is scheduled to be a week from today. It would be starting at 9:30 in the morning if we were in class. I'm simply going to turn it on all day long because the dean's asked us to do this. You can take all day long to do it. It is open book, open internet, open neighbor, open friend, wherever you want to. And then about Wednesday at 9 a.m., I'm going to cut off all stuff because I have to calculate grades and turn them in. So by Wednesday at about 9 a.m. in the morning on May the 6th, have everything turned in, ready to go. And then I can get that to the dean, and then we'll get mad at me for being late for my work. Okay, let's see, any more? Okay, I'm going to go ahead and go on mute now and hang loose here for a couple of minutes if there's any chat questions. And been nice working with you guys this semester, and please report back next Tuesday and take your final exam so I can promote you out of the class, and you're going to get badges from Cisco for completing this course with your new thing. Okay, guys, see you soon.